The sustainable valorization of fruit peel waste represents a powerful intersection of food science, environmental stewardship, and human nutrition. As global food systems contend with rising waste, nutrient shortfalls, and ecological degradation, the transformation of fruit peels, long treated as industrial byproducts or domestic refuse, into functional food ingredients is emerging as a compelling solution. The hypothesis that converting these peels into value-added ingredients simultaneously promotes sustainability and delivers measurable health benefits is not only logical but increasingly supported by a growing body of multidisciplinary research. Fruit processing industries generate enormous quantities of peel waste. In the citrus juice sector alone, peel and pulp residues account for nearly 50% of the fruit's mass. This waste often ends up in landfills, contributing to methane emissions, or at best, is composted without economic recovery. Yet citrus peels are rich in pectin, limonene oil, flavonoids like hesperidin, and essential oils with both culinary and pharmaceutical value. Technologies that extract these compounds via cold pressing, supercritical CO2 extraction, or enzymatic hydrolysis are now scalable and economically viable. Orange peels, for example, can be processed into pectin for use in jams and confectionery, essential oils for flavorings or cleaners, and fiber supplements for both humans and livestock. Similar pathways exist for apple peels, high in quercetin and pectin, banana peels, fiber and polyphenol, and mango peels, carotenoids and phenolics. From a nutritional perspective, peel-derived powders and extracts are dense with bioactives. These include vitamin C, A, E, and K, along with potassium, calcium, magnesium, and dietary fibers, both soluble and insoluble. When incorporated into flours, beverages, or nutritional bars, these ingredients enhance fiber content, antioxidant capacity, and in some cases reduce the glycemic index of foods. Multiple studies show that baked goods fortified with peel powders, e.g., mango, banana, citrus, exhibit increased antioxidant activity and improved satiety effects without compromising taste or texture when formulated correctly. The health benefits of such incorporation are not theoretical. Polyphenol extracted from citrus and grape skins have demonstrated anti-inflammatory, lipid-lowering, and blood pressure modulating effects in both animal and human trials. Pectin extracted from peels lowers LDL cholesterol, binds bile acids, and supports gut health through fermentation into short-chain fatty acids. Banana peel flour has shown promise in enhancing gut motility and providing antimicrobial effects. These functional applications, once considered fringe or suitable only for animal feed, are increasingly finding acceptance in human food development, especially in contexts aiming to address malnutrition, metabolic disorders, or food insecurity. Economically, valorization opens pathways for small and large producers to generate value from waste. Developing countries with high tropical fruit production stand to benefit most, as the infrastructure cost to process peels is far less than the cost of importing synthetic food additives or supplements. For instance, processing pineapple waste into bromelain-rich flour or beverage additives leverages an underused enzyme with proven digestive and anti-inflammatory benefits. Likewise, papaya peel and seed flours, once discarded, can be refined into antifungal powders or antioxidant-rich animal feeds, replacing synthetic inputs. Environmentally, life cycle assessments, LCA, have demonstrated clear reductions in carbon footprint, water usage, and landfill volume when peel waste is upcycled. For example, the LCA of citrus peel valorization into pectin and essential oil yields lower emissions and waste compared to traditional disposal. Such models help quantify the true sustainability gains and support policy shifts that encourage circular food economy models. A core research direction is optimization, determining the best drying methods, freeze drying versus oven drying, extraction techniques, solvent-free or enzymatic, and formulation strategies to preserve and deliver bioactives. Studies show that freeze-drying better retains vitamin C and polyphenol in peel powders, while enzyme-assisted extraction can improve pectin yield and purity. These process innovations allow for the tailoring of peel-derived ingredients for specific food systems, whether as emulsifiers, antioxidants, fiber enrichers, or colorants. Public acceptance remains a barrier, but one that is surmountable with education and marketing. Surveys reveal that consumers are more willing to purchase upcycled food products when benefits are clearly labeled, especially when terms like antioxidant-rich, natural fiber, and zero waste are used. In this sense, The valorization of peels is not only about processing, but also about reframing peels from refuse to resource. In sum, the hypothesis is robustly supported. Systematic valorization of fruit peel waste indeed yields dual benefits. It enhances health by restoring underutilized nutrients into the food supply, and it significantly reduces environmental impact by repurposing waste. The process of converting peels into value-added food ingredients is not just a technical innovation, but a shift towards circularity in nutrition science, a shift that aligns ecological sustainability with the evolving demand for functional, nutrient-dense foods.